And we have got those. Normally we call it a paradigm. Okay, we call it a paradigm when it comes to programming languages. There are those what we call procedural programming languages, which is about writing procedures or functions. Mainly, it will be function out of after function. But when it comes to object-only programming, here we'll be creating objects that contain both the data and what and the methods. So everything around this idea now is what is an object, something like that. So that's the object-oriented programming, right? So object-oriented programming has several advantages over those procedural programming languages. What is that? With OOP, we say it is faster and easier to execute. It provides a clear structure for the programs. Uh, we look at this when you talk about polymorphism, when you talk about inheritance, when you talk about the concept of classes, the concept of objects, and all those things. So it helps to keep the Java code dry, like don't repeat yourself, right? And it makes the code easier to maintain and modify as well as debugging. OOP makes it possible to create full reusable applications with less code and shorter development time, just like that. So normally when it comes to OOP in Java, we normally talk about what we call a class and what we call an object. So these are the things that we've been using in the previous tutorial. We've been talking about it, but this is how we official. It's like now we are introducing the concepts now with the object-oriented programming. So when it comes to what we call a class, we always say a class is the blueprint where we create an object. So for you to have an object, you need you need a class. So class and objects are the two main aspects of object-oriented programming. Look at the following illustration to see the difference between classes and objects. Like here, we can talk of a class as as a fruit, and the objects as apple, banana, mango, something like that. So the class will be fruit. So you have a class of what? Of fruits, right? And then the exact types of those fruits are now what? Objects of the class what? Fruit. So you could have an apple as a fruit, a banana as a fruit, a mango as a what? As a fruit, something like that. Another example is of a car where you could have a Volvo, an Audi, and also a Toyota there as a what? As an object of a what? Of a class car, something like that. So if you look at it, these classes are real world, right? Are real world things or real world objects, right? So you create a class and then you put the description so that you can create a copy or instance of that class. And that instance is what we call the object, right? Just like that. So that's the class and an object. So a class is a template for objects, and an object is an instance of a of a class, just like that. So when the individual objects are created, they inherit all the variables and the methods of the class from the class. So whenever you create an object of a class, you need to know that every variable, every method which is within that class is also now belonging to what? To that object that you've created, something like that. So it will inherit all the variables and the methods from the class. So let's look at these classes and objects. Like how do you create an object? How do you create a class? Something like that. I think we've done this before, so I'm not going to waste much of our time. But I think it's always good to look at the basics. Why? Because these basics are those which are very, very important. Why? Because if you know the basics, it will be easier for you to add other things later. So everything in Java is associated with the classes and objects along with its attributes and methods. We've talked about attributes and methods when we were talking about variables as well as methods. I think we've done this in the previous lesson. We've been talking about these methods, something like that. So methods are the members of a class, though, and also the attributes. Those the instance variables that you create are also what? Members of a class, something like that. So a class is like an object constructor or a blueprint for creating a what? An object. Here we have got to create a class, you use the keyword class. So whenever you want to create a class, you use this keyword class, and then you give the name of that class, something like that. So basically, that's how you do it. If you want to create an object, this is how you create an object of the main class. You need to say the name of the class, then the reference variable name, whatever that you want. You want to create my obj, something like that, and then use the new keyword to create a new object, and then uh you repeat, or you give it a constructor, something like that, or you repeat the name and then something like a method calling, and then you terminate, something like that, and then you could use the object to access the members of the class. So basically, that's how you do it. I want to clean up this whole code to make sure that okay, I think it is because of this. I'm trying to print something which is no longer there. Okay, so sorry, if you look at this, this one, you've got a class test, and then so whenever you say test t1 is equals to new test, we have created an object of class test. So if you say t1 dot, so what happens is there is now all these methods which are already there for this object, but if you look at it, we didn't create anything in here. So if I say int num, maybe it's called 6, something like this. What happens is when you create this object will now have this num, or this copy of this num. So it will inherit this variable, and it will keep its own specific memory space. Why? Because this is not a static variable. I think I've demonstrated on this in the last. So if I say t1, now I can get this num, so I can make use of this variable, something like that. So if I create also t2, like as an object of this class, I'm going to have t2 here, and this t2 will be able will also inherit this num, or this attribute, right? But it will keep its copy. So if you change the value for t1, you will be not change the value for t2, unless if it's static. Why? Because if it's static, it will be belonging to the what, to the class, something like that. So normally that's the object and the class, something like that. So this is how you create objects. Da 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 da. So if you want to use multiple classes, we'll talk about this later. Let's talk about the attributes. The issue of attributes, I think I've talked about this. So we've talked about variables, something like that. So when I talk of attributes, you talk of these variables that you declare, something like that. So these attributes are the ones that describes the object. So you'll be having the object, and you'll be having the attributes and the method. The method is now how the object behaves. Like if you have a car, you could have a color, whatever. Those things are the attributes. But now when you say car starts, now you need a method to start a car, something like that. So these attributes, then they are what they are. Then there are methods. So we take attributes as fields, or as what, or as a variable, something like that. So how do you access this attribute? You can access attribute by creating an object of the class, and by using the dot, like what you are using. This the dot syntax, like saying my object dot x to access this x here. That's what you do. I think we've been doing this. If you want to modify, just change the value, just like this. I think these are basic things that you can do. I don't think we need to spend much on it. But guys, if you find it challenging, please do ask. I might think that it's something that you are good at, but please do ask if you feel that you still need help on that. Right, so let's look at the issue of class methods. I think we've talked about this. On the issue of methods, we've talked about this. Allow me to skip this part. There's nothing new here. On how do you access methods, we've talked about this, and we've done even to a point where we could do maybe the issue of constructors, where we could do the issue of overloading. Let's talk about constructors quickly, because we didn't talk about constructors, right? So a constructor in Java is a special method that is used to initialize objects. So at first, you need to know that a constructor is a method, right? So why is it now it have a different name from what? From methods. It means that it have a special meaning, right? So a constructor is a special method that we use to initialize objects. So whenever you're creating an object, we want to give it maybe some initial data. So you use the constructor to give it the exact initial data that you want the object to be created with. Remember, when you're creating an object, it will assume or it will inherit all the what? All the objects, all the attributes of a class and its methods. So what if you want to say, when I'm creating this specific object, I do not want it to have, maybe it's an integer variable. I do not want it to have a 0 at this integer variable, but I want it to have this specific value, something like that. So the constructor is called when an object of a class is created, just like that. So whenever you're creating an object, you always call the constructor. So it can be used to set initial values for object attributes. So you need to know that if you do not create an object, a constructor, then Java will do it for you. That's it, just like that. So here, like here, if you say test, so if you say test T1, like what you are doing is equal to new test, something like this, and then you do this. What it means that here you are calling a constructor. This one, it's a method calling. You are calling a method, and that method is a constructor, just like that. So if you didn't create any constructor there, Java will do it for you. So there's that a constructor that we always call a non-parameterized constructor, or the default constructor, which will be always called by Java. We call it not a non-parameter, but it's a default constructor. We call it a default constructor. It will be called by Java whenever you do not create a constructor. So normally the constructor, there are rules of creating constructors. I thought they would be here, but normally the rules are that whenever you're creating constructor, you must have the same name as the class. Like you've got main, so the same name here. So it's a method, so it will be having the same here, and it doesn't return anything, right? It doesn't need to return anything, even if void there. So it will be just main, and then you open and you close, then you put whatever you want to put there. Like here, I've got int num is equal to 6. What if I want to change this num during the creation, and then whenever I want to run this? Okay, so let me say sys out to demonstrate on this, and then here I want to print T1, right? T1.num. I want to print this number here, this variable, right? And see what I'll get here. Let me run this. I'll get a 6, right? Just like that. So what if I have test here, like this method, right? So in this method, what am I going to do? I'm going to say this dot num should be initialized to 8 when I'm creating this, right? So let me run. You could find that now I'm getting an 8. Why? Because I'm calling this constructor. And what is this constructor? It's this constructor which is here. Was here I didn't pass any number, right? So it's giving 8 here. So what if now I want to have a constructor, like when I'm declaring it, I want to give it a specific value. When I'm creating the object, right? I want to give this a specific value. So what I need to do is to take an integer here. Let me say number, just to differentiate it. So here, this will be equal to number. So when I'm creating this, I want to pass a number like 9, like this one. So what happens is when I run this, so I will call a method which is taking one integer, right? And that method called the test is this one, which is take one integer. And then I'll pass to this number, I'll pass this value to this variable, which is this one, something like this. So if I run this, I'll get a 9 there. So what if I create a new object here, like this? I'm create a new object, and this object, I'm going to make it T2. And then here, I'll give it a 10, right? Let me just say a 20. So if I want to print here, I want to print this. So let me put here some space so that it won't be added. If you do not do that, otherwise it is going to say 9 plus 20. I do not want to do that. So it will do, so this one will become a string concatenation. So I say T2 dot num. I want to print its num there. So I need to get a 9 and a 20 and space then 20, something like that. So this is what I'm getting here. Why? Because during, so are you seeing that this would keep different memory? This T1, you've got its own num. You've got, both have inherited, T1 and T2, both have inherited this num variable. But this T1 will be keeping its own memory space on what it have got inherited from the class, and T2 will do so. So you find out that even if I change here to T2 and change here to T1, you would say that also the values will interchange. Doesn't mean that when I put T20 here, so because I have put T20 after putting a 9, so here I'm getting a 9 and here I'm getting something like that. So if you do this, you see I'm getting a 20 and a 9, just like that. So this value would be specifically for num in T1, and this one will be specifically for num in T2, something like that. So basically, that's the constructors there. So you can have a constructor that takes many. So whatever that applies to general methods also applies here, only that the way you name it, the return type, it doesn't return void, whatever, it doesn't return anything. Also, it needs to have the same name as the class, but it can have many parameters, as many as you want, as many as parameters as you want, something like that. So that's the constructor there. I don't know if I've got left anything there. Then there is this keyword. I think you have seen me using this keyword here. If I put num here like this and put num here like this and remove this like this. So here, if you look at this, what is happening there? It means that this num and this num and this num is looking like, not it's looking like, but it's the same variable which is being used because I'm here in the local method. But for me, I want to initialize this num, which is here, this variable. So normally that's when this keyword comes into play, right? So if you look at it, this keyword in Java refers to the current object in a method or a constructor. So whenever you call, or whenever this object calls this constructor, so it will be calling this constructor. So that method which will be executing this constructor is the one that we'll be referring to. So if you want a variable which is within that object, you use this keyword to access, right, the value of that variable, or of that variable within that object, something like that. So if I call this method while creating T1, it means that I'm going to change only the value for this object T1. So that's that's the use case of the this keyword. So it normally refers to the current object which is executing that method. So this keyword is often used to avoid confusion when a class attributes have the same name as as a method, or as as a constructor parameter, something like that. So normally that's how you make use of this keyword. Does it make any sense? Think that's calling a constructor from another constructor. All these things, you can look at them later, but I don't think they are very much of interest. You can look at them later, but normally that's how you make use of this keyword there. And I think the next thing that we need to talk about is the Java modifiers, right? These modifiers, they are very important. The access modifiers, they are very important. And also the non-access modifiers, they are very important. So by now you are quite familiar with the public keyword that appears in almost of our examples, right? So this public keyword, it means something. So the public keyword is an access modifier, meaning that it is used to set the access levels for classes, attributes, methods, and constructors, right? So normally that's I think the person who was supposed to accept people here is sleeping at work as well. Okay. So I was saying that these access modifiers, they help us Normally, when you want to do inheritance, whatever, now when you're talking of OOP, you find out that you'll be mainly looking at these access modifiers, right? So they are divided into two categories or into two groups. The access modifiers, which controls the access levels, and then the non-access modifiers, which do not control access level, but provides other functionalities. So when you're talking of access modifiers, we'll be talking about so for classes you can only use either the public or default, right? For class you can only use the public or the default. So you need to know that when you're talking of the public, which is the class is accessible by any other class. So if you mark your class public, it means that this class is accessible by any other class that needs to access that class or that wanted to make use of that class, right? And then the default access modifier, the class is only accessible by classes in the same package. When you're talking of a package, you're talking of a folder. If your classes are in the same folder, it means that if you give it a default access modifier, it means that it can be accessed by any other class which is within the same folder. That's the same package. So this is used when you don't specify a modifier. So if you come here and say, when you are declaring class, when you say public class, if you just leave it like this, like class test, what happens there? This class is going to be given, this class test is going to be given default access modifier, and it is going to be only accessed or able to share its data, whatever, with the classes which are in the same package with that class, something like that, which are in the same package. I forgot what's the name of the project. It's a demo project. I wanted to open some. Okay, so it is this one. So if you look at it, we've got this folder here, which have got this test class. Yes, this one. So if I create another, so I've got this demo.java. Okay, this one as well, which is within the same what do you call it, within the same, it is also within the same package, something like that. So if you mark it this one, if you mark it like this, it means that I can even access its members from here using whatever the concepts, any concepts that I want to pick there that can make it happen of object-oriented programming. Excuse me, I can access it, something like that. So that's what you're talking about there. Okay, so now let's look at for attributes, for attributes, methods, and constructors. You can only use the public, the private, the default, and the protected. So normally, when we're talking of private and protected, I think we've already talked about this public here. So when you are using public, the code is accessible for all classes. So if you mark a variable public or a method public, it makes it available to any class which is inheriting from that class where there is a variable there, something like that. And if you make it private, the code is only accessible within the declared class. So if you declare something in this class here, like in this class, and you mark it private, it means that it is going to be only accessed within that class. Hakuna futhi chimwe chinokwanisa kuaccessa that data, something like that. I want to remove all these things so that I'll make this a little better. Not a junk screen, something like that. So the default is the one that we've already told that if you do not make it public, private, or protected, it is going to be given the default access modifier. So the code is only accessible in the same package, just like that. So it will only happen in the same folder, like what I said before. So this is used when you don't specify a modifier. So the protected, I think it's just as good as the default one, but the code is accessible in the same package and the subclasses. So it's as good as the same as the default, but there is also the issue of subclasses. So if you create subclasses, if you are using protected, it can be also accessed through inheritance, something like that. So that's what it means there. So now there's the issue of public versus private. For this example here, they were using this example where you could have these classes, the class person and then the classmate there, then the private and the public there, and then they are trying to access those things from another class. So without the use of inheritance, let me just create another simple class here, right? Let me just create another simple class. So here I would say class, maybe person, just like that. And then in this class, what I'm going to have, I'm going to have a private string name. Then I would say Ezekiel. Then I have public, something like that. Public. It's public int age. Then I'm going to give it, maybe it's 50 years old. Then I will say here, now I want to try to access these objects in a class. So how do I, not objects, but these variables. So how do I access them in this class? I am supposed to create the objects of that class. So I will try, I want to align this so that it looks better there. Or let me just remove it. Okay, so what do I need? For me to access this and this, maybe I need the object of that class. So I will say person, maybe P is equal to new person, something like that, and then I'll terminate. So now because I have this P here, let me try to print out this. And in here, I'm just going to say P dot. When I do so, you find out that I can print age, right? And if I run this, I could get the age is 50 there. But what if I want to print this string name? So this name, the name there, if I try to say name, I'll get an error there. Why? Because it will say that the field is not visible. Say it's not visible. So what you need to do there, it will tell you the quick fix to change visibility of name to package level, or create a getter or a setter method for name, so that you'll be able to get to access it, something like that. So that's how the private affects your code there, and that's how the public also affects your code. So if you make it private, forget if you want to access it, something like that. I think it's something which is simple. If you want to access it here, you need to make it public, something like this. You need to make it public. By doing so, boom, everything is fixed, and then you can run your code just like that. Okay. Maybe what do we need to talk about? We need to talk about the non-access modifiers. So non-access modifiers do not control visibility like public or private, but instead add other features to classes and methods, and attributes. And the most common used non-access modifiers are final, static, and abstract, right? So for final, if you make something final, you know that it's now a read-only thing. If you make it static, it now belongs to a class. And then if you make it abstract, we talk about this when I talk about abstraction, right? We are going to talk about abstraction here. How do you achieve abstraction, whatever? We're going to talk about that. It's also a non-access modifier. So if you don't want the ability to override existing values, values declare attributes as final. So if you make it final like this, it means that this X, you are not going to change it. So it's going to be a read only, something like that. If you mark it static, I think we've talked about this. If you mark it a method, if you mark a method static, then that method belongs to the class, not to any specific object. This means you can call it without creating an object of the class. I think you've talked about this. If you mark it static here, like this one, whenever you are creating objects of class person, it means that all those objects that you are going to create will be sharing the same name, something like that. It's now different from what I was saying. If you have T1 and T2, then it separates memory. Each object will have its own data, whatever, something like that, it will be different. If you mark it static, now it belongs to the class. Hence, you'll be sharing the same memory, something like that. So that's it with the non-access modifiers. For abstract method belongs to an abstract class and it does not have a board. We are going to talk about it when we are doing abstraction there. And the board is provided by the subclass, something like that. So we need to talk about this when we are done with inheritance, whatever, something like that. And then let's talk about Java encapsulation. So normally when it comes to object-oriented programming, you have got 4 concepts of object-oriented programming, and you need to know them, right? So you've got this encapsulation, you've got inheritance, we have got polymorphism, and we've got abstraction. Those are the 4 concepts of object-oriented programming, right? So you need to know them, and you need to know how to achieve them, and you need to be able to give an example of those things. So in general, this is all about that will be all about object-oriented programming. Only that we will be saying you cannot learn object-oriented programming without learning Java there. Why? Because that's the language that you are going to use for you to learn that. So you find out that there will be a part where you'll be learning or where you'll be asked about Java, whatever. And then there is OOP there, which is encapsulation, polymorphism, inheritance, and abstraction. How do you achieve it? Give example, something like that, and maybe to differentiate. How does it differ from the other? Whatever. What are its advantages? What are its whatever? What are its benefits? Something like that. Why do we need encapsulation? Something like that. What are the benefits of having encapsulation? Why was it added to the concepts of object-oriented programming, something like that. So normally when you are talking of encapsulation, the meaning of encapsulation is to make sure that sensitive data is hidden from users. To achieve this, you must declare class variables or attributes as private and provide public get and set method to access and update the value of a private variable. So in other words, you want to have control of your data there. Maybe you are coding as a what? As a team, right? You are given a task to do. Is that a question or contribution? Maybe if we make sure that we are always on mute. Okay, thank you. So saying that if you are coding as a team, right? And you are given your module there, you want to control your module. You do not want to just having your data being corrupted by other programmers, right? So this is the best way to do it so that that you protect your variables there and then or your data there. And then if you want, then you provide the getter or the setter method for that only specific thing that you want people to access. Something like that. So now you need to understand what is this get, what is this set method. So you learned from the previous chapter that private variables can only be accessed within the same class. An outside class has no access to it. However, it is possible to access them if we provide public get and set methods. So the get method returns the variable value and the set method sets the value. So normally for each and every variable, you'll be having a get and a set method. The get is to get the value of that, so it needs to return something. The set is to set the value, so it doesn't need to return something. So it tells you that from that, it tells you that the get is going to return a value. The set is going to be a void method, something like that. So the get returns the type of the variable, something like that. If the variable is an int, so you return an int, something like that. So syntax for both is that they start with either get or set, following by the name of the variable with the first letter in uppercase. So normally if you want to get a name, you just say public string get name. If you want to set name, it's now public void set name, something like that. And also you need to take note that if you want to use the setter method, it returns void and it needs to take a parameter. But this one, the getter method only the getter method returns a type of the variable, and it doesn't take any parameter, and the naming conventions are just the same. Get, and then you put the name of the variable there. Get set, and you put the name of the variable, just like that. So normally that's how you achieve encapsulation. As simple as that, right? As simple as that. I don't think there is something there that needs to be more explained, but that's what it is there. So the key thing is to make sure that you make the variable private. Just like this, if I come here, now I will make all these private, right? Instead of making them public, I'll make them private, right? Private. But now I need to provide the getters and the setter methods, something like that. I need to provide the getters and setter methods. So what I would need to do is now, because it's a getter and the setter method, I need to make it public. So if it is a setter method I want to set, so it needs to return a void there. And then I will need to say set, then I'll say name there, because I want to set name, right? And it needs to take something. So I will put a string, and maybe I will say name again. And then I think we've talked about the issue of this keyword. So I will say this dot name. So this dot name will be initialized to name. So what it means that this name will be this name here, and then this variable will be this variable that I'm passing. I think we have talked about the use of this keyword. And then here I would say public, then I'll provide a getter method. So the getter method is going to return something. So I need to give it string here, and then I'll say get name, because I'm going to get name, right? Then here, what I just need is to return this dot name, something like that. That's what I only want to return. So if you look at it, I want this one to remain private, not being accessed, but this one I want people maybe to be able to change. So I provide the setter method and the get name. If you want to only them read it without changing it, you only provide the get the getter method. So you now have that control as well. So that's the benefit of having encapsulation in Java. You can control it. Either you want them to read, or you want them to read, both read and write, or maybe you want them to write only. So you provide the set name, you provide the get name whenever you want, something like that. So here, instead of this, I'll just say p dot get name. Instead of say name, I need to have the get name here, this one, for me to access the name. And if I run this, I'll still get is something like that. And if I want to change the name now, I can just say p dot set name here, and I need to pass the name for that. And that name should be something like, maybe here I can I can pass a string like John here. And after doing this, if I run, I'll get John instead of getting this is because I've changed it here. So that's how you achieve encapsulation. Just as simple as that. If you're going to be asked to give an example, this is a good example to give, right? So this edge will remain private and one would access it. And if you want, also you can just maybe take this one out. If you take this one out, you'll make it a read only, which means I will be no longer able to change the name there. What I just need, I will be able to access it, just something like this. So now you'll be having all that control. So that those are the benefits of encapsulation in Java, right? So what I'm going to do is I'm going to talk about inheritance. But I've jumped the issue of packages, which are folders in Java. I think I've already talked about it, that in Java, we've got folders. So you put the classes in what? In a folder, something like that. So a package is just a what? It's just a folder in Java, something like that. So I'm not going to look at some of these packages that we have. We have the util, whatever. We have got the util, the scanner class. Sorry, we have got the scanner class, whatever that we use if you want to take the input from the user. I think we are going to talk about this later on, but I don't think For now, I do need it. I don't need it. I don't need it. Let's talk about inheritance. I think that's what's very important for us today. So in Java, it is possible to inherit attributes and methods from one class to another. We group the inheritance concepts into two categories. There's what you call a subclass and a superclass. A subclass is a child. A superclass is a parent, right? So when you say you have got a subclass, that one is the class which is just inheriting or inherits from another class, and then the parent class is the class being inherited from, just like that, right? So to inherit or to use inheritance, we need to use the keyword extends, right? So we use the extends keyword for us to do inheritance. So this was just an example here where you have a vehicle class and then you have car extends vehicle. So what happens is that here we are avoiding to just repeating yourself, like what we're saying. So this one will help you to just write once and then you'll be able to reuse that code that you've already written, something like that. So I can have this class testy, maybe let me just have a class like what else can I do? Uh, I want to have this class extending another class, something like that. If I say, what's the best way to do it? Can I have this one to extend class person, right? So if I do this, what I'm going to do is, um, I want to make one default there, and I'm going to try to access it. Instead of using the object person here, I will be no longer, there will be no need of using that. What I would want is the test T, it's got a new test, something like that. Da, da, da. Okay, so now if I come here and say T dot edge, yes, it means I can access edge. If I run this, I'll get 50. Okay, so what it means here is that if you do this, I've got this class person, right? And this is private and this is not private. If I do not make it public, protected, private, it means that it have got default access modifier. So what it means, we've said if the classes are in the same package, like here, and I'm also inheriting, which means you can inherit. If you make it default, you can inherit it, but also you can only do that if you are in the same package. Otherwise, if it's in the other package, I think that's where you need the protected, the protected access modifier. So what is happening here is that everything in here which is inheritable is now available to use on the objects of class test, or it's now by virtue of this extends keyword, it now means that everything in person that I can possibly inherit is now available in this class. So I do not need to rewrite that code, right? Something like that. So because this method is public, I can also use it to get the name. So I can say get name there without rewriting this and without rewriting it here, something like that. So I can just get the name. So that's the concept of inheritance. But if you make it private, never, you cannot inherit it. So you need to know when the attributes can be inheritable. You can only inherit if it's public or maybe it's protected, and maybe when it is when it have got default access modifier. But if it is public, you can inherit even if classes are not in the same package or not in the same folder, right? But if it is protected, now you can inherit this from it is possible to inherit it from one package to another package, something like that. If you've got classes from different packages, something like that, you can inherit. But if it is a default access modifier, then you can only inherit it when classes are in the same folder, something like that, or are in the same package. If it is private, no inheritance. So that's how you control the level of visibility there for inheritance. That's what you need to know. I think that's the basic thing that you need to know there. Then there's what we call polymorphism. So guys, you just need to understand, why do we need inheritance? Something like that, right? Normally for code reuse, if you want to reuse the code, then come and use inheritance, something like that. But go and read more on inheritance, right? I just show you how to implement it, and so that whenever you are explaining, you can give an example, something like that. I hope the person who wanted to join was accepted. And then there is the issue of polymorphism, right? So polymorphism means many forms. So here I talk of one method which will be in many forms. Last time we've talked about method overloading, right? And that method overloading is also part of polymorphism. And then there's what we call method overriding, which is also part of what? Of polymorphism. So polymorphism, it occurs when we have many classes that are related to each other by inheritance. So like we specified in the previous chapter, inheritance let us inherit attributes and methods from another class. So polymorphism uses those methods to perform different tasks. So this allows us to perform a single action in different ways. So normally there's polymorphism through inheritance, right? So when you read around it, you heard that there's what you call runtime polymorphism and compile time polymorphism. Why compile time? Why runtime? When I compile the code, by that time I compile, it knows that if you run this code, when you're calling this method, the exact method up to all those same methods, whatever that we have because of polymorphism, this one is the one which is going to be executed, something like that. That's the compile time. Then the runtime, you only know the possible method to be called at runtime when you are now running the method. Like the logic now is the one which is going to determine something like that. So those things are the ones which will tell you which one is the runtime, which one is compile time, whatever, something like that. So for example, think of a superclass called animal that is a method called animal sound. So subclasses of animals could be pigs, cats, dogs, birds, something like that. And they also have their own implementation of an animal sound. Like a pig can have its own type of sound that it can make, a cat, something like that. So if you look at it, we've got animal with the method, this one which is public, the animal sound. But if you look at it now, we are now overriding that method and overriding that method, something like here. So when you're overriding that method, what it means that this dog now have got two methods in it, the method from the class animal and the one that you are writing here, right? But because this method, if you look at it, is just the same as the method from the superclass, it means you have overridden that method. You have give it now the new way of doing things or the new behavior, which means the pig now is using the same method, the dog is using the same method, but this same method is doing different things. Excuse me. So this one we call it polymorphism, where you would have one method in one in your single code there, whatever, and then you have one method there, the same method doing different things. That's polymorphism. So if you create a pig, a dog object, and the dog objects, and call the animal sound method on both of them, what do you get here? Like this one, let me just to run it on myself here. If I try to run this code, I'm avoiding to take it to my editor, so that because I will need to change almost the name of the class, whatever, something like that. Not the name of the class, but the name of the file. So if you look at it here, when you're now creating object, if you create an object of animal, and then create an object of what? Of pig and of dog. And then if you call those methods, if you look here, if you call the animal sound from this, you could just get the animal makes a sound. And then if you call the my pig object like this one, you could get this being executed, which is coming from the class pig, this one, this method. But if you look at it, we are calling the same method. But this method is giving us different output. This is what you call runtime polymorphism. And this is what we call polymorphism. And you can achieve it through inheritance, right? So the benefits are that you can have one method that you can use to do different things. That's polymorphism there for you. And that's how you can show it, right? And then the other type of polymorphism, which is comparative polymorphism, is the one that we did on the last tutorial, where we're talking about method overloading. We were using same method, but now it will have different return type, maybe different number of parameters, something like that. So that one is comparative polymorphism. But for this one, it needs to be the same. If you look at it with public, void, void, animal sound, here no parameters, here no parameters. That's method overriding. So you only achieve polymorphism through method overloading and method overriding. And on method overriding, you can only do it through inheritance. I think you need to understand that. So those are the key points. Those are the talking points whenever you are describing polymorphism, right? So the comparative polymorphism, that's the one that I was saying that you need to maybe like here. I think that's the one that's the one which was here when there was different methods here. Let me just take this out. Maybe taking this class as well out. I don't need it. I don't need it. So here, let me take this out as well for now. Maybe what I can do is I can have a class here and say, do I really need another class? No, I do not need another class. So here I can just have different methods here in the same class, right? So let me have int add, right? So this int add class, method is supposed to return. Let me just return 0 there for now so that the error goes so that I will be okay. So what I'm going to do is I'm going to pass int a and b and int b there. So what is going to happen here? I'm going to return a plus b, right? So I'm going to repeat this method, right? If I do so, I'll get an error. But if I change this one, the parameters, and add another parameter here, and so the error goes, which means it's the same method but doing different things. This one is adding 2 numbers, this one is adding 3 numbers, something like that. So this one you call it comparative polymorphism. Why? Because if I come here and try to call a method to add 3 numbers, what do I need is the object, and I'll say add, and then I want to take this one, which it takes 3 numbers. So by doing so, we already know that the method which is going to be called is this one, because it's only the add method which is taking 3 integers, 3 consecutive integers, something like that. So here I could put 49, here I could put 1, here I could put a 1 there, something like that. So if I add this 51, something like that, so I'm going to get a 51, something like that. So by compare time, I know that this is the exact method which is going to be called. It's now different from the runtime polymorphism. So this is that's polymorphism for you. So if you look at it, just the same method but different. um different number of parameters. You can also make use of maybe to change the types of parameters as well. It makes it different, or maybe to change the return type. Like here I can have string add something like this. What you just need is to return a string here there. Maybe let me just return something like this. So if you look at it, it's just the same add method, only that it's now returning a string. So the error goes. Why? Because this method is different from this method. It's different from this method, something like that. But the names are just the what are just the same. So you can use it different. So it's the same method, but you can use it differently. Hence, polymorphism. I hope it's well explained, unless if I've got any question there. Otherwise, I would move to maybe the issue of abstraction. There, we've talked about polymorphism, inheritance, encapsulation. Let's talk about abstraction. The issue of the super keyword, going to look at it. What is super keyword? How can make use of it? For now, let's look at the abstraction. Okay, so normally when you want to achieve abstraction, you can use abstract classes, or you can make use of interfaces if you want to achieve a true abstraction, right? So data abstraction is the process of hiding certain details and showing only essential information to the user. If you want to do that, if you want to hide some certain details of your program and only show whatever you want to show to the users, you can make use of what? Of abstraction. So abstraction can be achieved with either abstract classes or interfaces. So if you want to use interfaces, that's when you achieve the true abstraction there. For one good reason, you cannot create classes of interface, something like that. So the abstract keyword is a non-access modifier, like what we have said before, used for classes and the methods. So the abstract class is a restricted class that cannot be used to create objects. So for you to access its members, what do you need? You need to use inheritance. An abstract method can only be used in an abstract class. So you cannot have an abstract method inside a non-abstract class. And it does not have a body. The body is provided by the subclass or the class which is inheriting that. I think it's very, very simple and very, very straightforward. So here you have an example of an abstract class, right? Like this abstract keyword, sorry, I do not want to zoom, like this abstract keyword, and then the class name, right? And if you mark it abstract, it doesn't mean that it's not going to contain even an abstract what? An abstract. Sorry, a normal method, or those concrete that we call concrete methods, something like that. The methods that we used to have. Like here, let me just take out the issue of adding whatever, the issue of polymorphism, and then let me have I think I need to take this as well, this out as well. Them just printing nothing. Let me just print nothing there. So what do I want to talk about is the issue of abstract. Okay, so I can have an abstract class here. Let me, so I have to say class. Let me just say person, like what you used to do. So what it means that this abstract class, I can have a method here, which would be an abstract method, right? So to make it an abstract method, you mark it abstract. Abstract, so it can return whatever you want there. Maybe let me say int, add, like what you used to have. And then because it's an abstract method, it's not going to have a method. Not a method, but the body. It's not going to have the body there. Cannot have it as this and like this. You cannot have it like this because you mark it abstract, so it must not have a body there. Something like that. So that's what it is there. So that's the abstract class with an abstract method, something like that. But also we are saying this class can also have a concrete method or that method with a body, though it is an abstract class, something like that. So I can have here maybe string, instead of, let me just have it as a void, maybe let me name it what, get name, something like that. Because I said get name, now it needs to change something. Let me say set name, something like that, but I'm not going to. So if you look at it, you can also, it's possible to put all these methods, something like that. So that's an abstract class there. And by virtue of that, you have marked it abstract. It means that the class, now you cannot create objects of the class, what, of the class person. You can only make use of these contents by extending it or by inherit from it. So I need to extend person. So what happens is, because I've extended this class person, and this class person have an abstract method, this abstract method is already available here because I've inherited it, right? It's not public, but it have got a default access mode file, right? So I can inherit it. So it's already available here. So because we have said there is no class which is going to have an abstract method, and that class not being an abstract class. So here we have an abstract method in here that we have inherited here, but this class is not marked abstract. So we're going to have an error. So how do you make that error go? You need to implement or to override every abstract method which is from the class that you have inherited. Otherwise, you are forced to mark that class also what? Abstract, something like that. You'll be forced to do so. So the error is that because you cannot create an object of an abstract class, something like that. So what do you do to make the error go? Now you need to create a method int add, and then give it the body. By doing so, then, so it was what? It was int, so it needs to return something, right? Let me just return maybe 40 there as an integer, so the error will go. And now we have this method implemented. So you can have some of the methods with the body implemented, whatever, and then there is that area that you want to hide. That's the one that you make abstract there and not give its implementation, and only do that through inheritance. You give its implementation whenever you feel that you can now give it. So that's the control that you're now giving to your code through abstraction. So you need to understand what is this animal. But otherwise, that's how you make use of abstraction there. I don't know if there's anything new that would be new here. I don't think there's anything new. So basically, that's the those basics object-oriented programming concepts. We've got encapsulation, we've got polymorphism, we've got abstraction, we've got inheritance. Those four. And that's what we wanted to cover for today. I don't know if I've got any question. Otherwise, what you need to do as well is to read about these Java collections, and maybe I'll just pick a few of these data structures, the list, the array list, the linked list. I think these are the basic things that you can build on if you want to learn the sets, whatever, the tree set, the hash set, whatever. But I think if you have these basics, it will be good for you. If you want to learn every data structure here that you are seeing here, later on it will be easier for you to do that. Maybe what I would want to talk about as well is the issue of threads in Java, something like that. But those have nothing to do with the object-oriented programming concept that we're talking about. But otherwise, for now, I would ask if there are questions, contributions that you have. Maybe I would say that that's what we're supposed to come for today. I don't know if I've got questions, contributions, which means everything was well. If there are no questions, if there are no contributions, start so. Am I even audible? Kelvin, you want to say something? You can unmute yourself.
Okay. Yeah, I want to say something. So I noticed our lessons are going on perfectly, but I feel like we now need practice on our own. Like you give us questions that we can maybe discuss on our WhatsApp platform with others, so that we can see if we have understood these lessons. I don't know if it's wise.
It's okay, thank you. Though that's why you have got assignments, but it's okay. Um, what I would do is I always ask you to come up with those questions as well as interact in the group as you are doing the questions, something like that. Maybe someone will come with whatever that you want to ask. I'm doing this, whatever, blah, blah, blah. Otherwise, it's very, very easier to do that. There are simple codes that you can do in Java, and then whenever you get an error there, then you can ask in the group or whatever. It's very, very helpful. I'm doing those we are doing computer programming, the part ones that I have. It's very, very useful. They are doing that, and you find out that by the end of the day, you're having 100 messages in the group. But for me, I will not feel offended to go through those messages because I'll be seeing that they're actually learning. And you see that out of all the class, maybe there are still few people who are struggling. Why? Because they're just helping others. So maybe I'll give you the questions, but I think it's good for you to take the initiative and then discuss with the class. Then move. You want to say something?
Yes, thank you, sir.
Yeah.
My issue has been on the type of assignments that we have had so far,
Okay.
which are just quiz structured. Yet from experience from C++, the assignments have been programs, writing programs that perform a particular issue. So I would like to support Kelvin because come exam, you might then struggle to come up with, a program that will answer the question in the exam. Thank you.
Okay. Okay. But I don't know. On quiz two, I think there were questions as well which were requiring you to do some program. I don't know. Unless if it's not this module. I've got a lot of modules. I tend to forget some of these things.
I haven't attempted that one yet. I was waiting for this second online lessons.
Okay. I think on quiz two, there's such questions which where you are supposed to actually code. I think there are questions like that. But after all, make use of the past exam paper to come out to come with those questions or whatever and do whatever. But we are going to have a final tutorial as well where we'll be going through the series of how do you answer those questions, how do you code, how do you like if you are given a problem, how do you solve that problem. I think we are going to do a live stream on that one as well for this module. I think we'll do that as the final tutorial for this module. Okay, I think I will take Mufre, you want to say something again? You can unmute yourself if you want
Yeah,
to
so
want to.
I put my hand down. Yeah, I'm,
Oh,
I'm doing it on
okay,
kind
so
of
it's
new on a
okay.
laptop.
Okay, Kelvin,
Thank
you
you,
want
sir.
to say something? Okay, it's okay. Kelvin, can I unmute yourself?
Yes, I wanted to ask where we find those past exam papers. I think using past exam papers is a noble idea, like you mentioned.
On portal, do we not have past exam papers on your portal? I think on your portal you could access them.
Okay. I think we can access them on our portals. Thank you.
Okay. So guys, for today, I think I can call it a day. I can call it a day. If there's a hand by Anis, so you want to say something, can unmute yourself. There's no problem. Can unmute yourself.
Hello, can you hear me, sir?
Yes.